Okay, then we got inequalities. Write an inequality that represents the graph. All you do is put a variable, use x, put 4 after it, and then if it goes that way, okay, that's greater than right there. If it's filled in, equal to. Okay, put x first, -6. This time it's going this way, that is less than. Don't put the line because it's not filled in. Now, what you have here, when they spread apart like that, I write the word or, and I just do them separately. I go x2, this way is greater than, don't fill it in because it's empty. X -7, that way is less than, okay? So less than. Okay, now here, this time when they combine, you put x down just once. On one side you put the -7, the other side you put -1. -1's the maximum your graph ever gets to. So any sign should eat the -1. We'll put the line because it's filled in. Nothing should eat the -7, okay? -7 is the smallest number you can have, so don't eat the -7. Basically, when they're like this, the signs will go the same way, okay? You'll have a less than here and a less than here. Because we're putting because we have to eat the x here, we have to eat the -1 here. Okay, now, solve each inequality, graph the solutions, and label the answer. Here's what I mean by that. You make your number line. Now, a couple things you're going to want to do here. Make sure you know what your x multiplying number is. It's a 1. It's positive, so the sign stays the same. Okay, then we get the -6 to a 0 by adding 6. Don't come down here until you've either divided or crossed out the 1. Don't come down here when you're adding and subtracting, so that's 4. You can either divide by 1 or get rid of it, so you got x, 4. So 4. Now, as far as what way do I go, does it eat the x or doesn't it eat the x? Looks to me like it eats x, so we're going to go this way. Now, label means this. You put x and 4, and when we go that way, that's a greater than or equal to sign. Okay, number 6. Now, this time the x has a multiplier of -2. Okay, so since it has a negative multiplier, we need to change the sign. It needs to go the other way. Now, I can go straight to the dividing because I don't have to get anything to 0. I'm ready to divide right here. So I'm going to divide by -2. And I'm going to have -8, line it up, and then x. So plot your -8, circle, you want to fill it in. Now, does it eat the x or not? No, it doesn't eat the x, so it goes this way. So that means I put x with a less than or equal to sign, and then -8. You can see I flipped it. The order's kind of flipped right there. Just follow these rules and you can't go wrong. Okay, what's your x multiplier number? It's -2/3. It's a negative, so the sign flips. I don't have to add, I don't have to subtract, I can go straight to dividing by the fraction, -2/3. So I have x on the left. On a calculator, 10 divided by -2 ABC3 is -15. Now, does that eat the x? No, it does not, so it goes this way. Don't fill it in, though. So that way is less than, I put x with the less than or equal to sign, -15. Okay, keep it rolling. Number 8. Well, I don't know what I'm going to do with my sign because there's a parentheses there, so I need to apply the distributed property. So 6 times 1x is 6x minus 6 times 1 is 6, less than -18. Now I know what to do with my symbol. The multiplier is a positive 6, so the sign stays the same. But before we divide, we got to get rid of that -6. We add 6. Don't go down here yet. That's going to be negative 12, and over here you got 6x. Now we can divide. When I divide, I now have my number I'm going to plot. Okay, does it eat the x? No, it does not, so it needs to go this way. Not filled in because the line's not there, so I label it with x, negative 2. We go that way, that's less than or equal to. No, less than, but not equal to, sorry. Don't put the line. Okay, number 9. I don't know what I'm going to do with the symbol because there's two x's. So let's get the 1 over here to 0. Because if I get rid of that one, there'd be nothing there, which would confuse people. Negative 3x and then negative 18. Now that you only have a single x, you know the multiplier, negative 3. So gee, it's negative, so I want to take the symbol and flip it because I will be dividing by negative. And I don't have to add or subtract, I can go straight into the dividing. So we got x and then 6. Okay, does that look like it eats the x? Yes, it does, so it would go to the right. Great. And right is greater than. X, 6, greater than or equal to. Now, the next ones are compound inequalities. Okay, when you see two symbols, we're going to make our number line, and then we're going to make our chart. Okay, when I see two symbols within the same problem, I do the overlapping circles. On this side, I've got negative 1 less than or equal to 2x minus 3. Then on the other side, 2x minus 3 less than or equal to 11. So my multiplier is 2, so the signs aren't going to, symbols will stay the same. If that was a negative 2, I would flip them, but since it's just positive 2, I leave them the same. Okay, get that minus 3 to a 0, add 3. Line your sign up, and that's 2, and that's 2x. Dividing by 2, that's 1, and then x. Now let's go over here. 14. Dividing by 2, x, and 7. Okay, now which way do I go? I plot the numbers 1 and 7. So let's look at the 1. We're going to fill in the circle. Does it eat the x? Yes, it does. It eats x, so it has to go this way. Now the 7, does it eat the x? No, it doesn't. So it goes this way, and they combine into 2. So when they combine, you write x down one time with 1 on this side, 7 on this side. You eat the 7 there, and you eat the x here. Because it's eating the x here, it has to here. Eats the 7 here, it has to here. It has to eat the same thing that it does at the end here. Okay, then another table problem, because I see two symbols. So 3x less than negative 9, but this one doesn't overlap. Two separate. Okay, both multipliers are positive, so the symbols on both sides will stay the same. I don't have to add or subtract, I go straight into dividing. So we got x, negative 3. Oh, sorry, I can come down here, can't I? X, negative 3. Go straight into dividing. That gives me x and 5. So I plot those numbers, negative 3, positive 5. Don't fill in either circle. Does it eat x? No, it doesn't, so it goes this way. Does it eat x? Yes, it does, so it goes this way. So that's the or. All you do is simply copy these down on the label. Make sure you eat the negative 3 just like here. Make sure you eat the x right there. Okay, now absolute value. Okay, inequalities. You're going to make your table again, just like you did on the last one. And what you write is you put 2x minus 7 greater than 1. But on the other side, you go 2x minus 7, and you flip the sign so it goes the other way, and then you make your 1 a negative. Because absolute value, to have an absolute value of a certain number like 1, you can be at 1 or negative 1, but with the symbol, you got to flip it when you do the negative. then you do it the same way. Both the multipliers are positive, the signs will not switch. First we got to add 7. So that's 8. Divide by 2, that's x, 4. That's 6. Divide by 2, I've got x, 3. Okay, so 3 and 4, those are going to be pretty close together. That's all right. So look at the 4. Does it eat the x? You bet. The 3, does it eat the x? No. It needs to go this way. So that's an or. With or, you write x's separately, and you simply eat the x with the, eat the 3, and then eat the 4 right there. Okay, solve the equation. Now these are just equations. We don't need the number line because there's no symbol. It just says equals. You're going to make your table, but you got something outside the absolute value. You got a plus 4. When it's outside, that's called a k value. We add or subtract k values. Okay, so minus 4, that means we have 3, and then we have the absolute value x plus 2. So we have x plus 2 and x plus 2. Now to have an absolute value of 3, we can be equal to 3 or equal to negative 3. And then you just solve them. So x equals 1 there. And then negative 5 right there. You don't have to graph them because which direction would you go? Because it just says equals. Okay, 14. Make your table in that box here. Now you got x plus 5, you know you're writing that down, but you got a value outside. You got a number, but this time it's in front, okay? That's called an a value. To deal with a values, we divide by 4, because a values are multiplied by the absolute value. Don't do the distributive property. So that's 2, and then we got x plus 5. So that could be at 2 or negative 2. So 2 minus 5 is negative 3. Negative 2 minus 5 is negative 7. So those are your possible values for x. Just discrete values. They don't go on a number line and be continuous. Okay, story problems. Number 15. We have 240 feet of fence to put around a rectangular garden. The width of the garden has to be 50 feet. Write and solve an inequality that represents the possible lengths of the garden. Now have, okay, the word have, okay, insinuates less than, okay, insinuates less than. So you put a less than sign, and you're going to have 240 feet. That's what you have. Now, let's talk about the lengths and the widths, because I'm going to put fence on all sides. Well, there's 2 lengths, 2 times the length, and also 2 times the width. Well, I know the width. The width has to be 50. Okay? So 2 times 50 is 100. And 2 times L is written as 2L. So I write 2L plus 100, and then I just solve it. Okay? Positive multiplier sign stays the same. You put the bar under because you could be equal to it. So minus 100 minus 100. So it's 140 and then 2L. Divide by 2, and you got L less than or equal to 70 feet. If you're at exactly 70, then you use all your fence. If you go under 70, then you'll have fence left over, but you can't use more than 70. Okay, my goal is to average 90 on my test in geography class. So far I've scored 87, 97, 89 on my first 3 tests. Write and solve an inequality that represents the possible scores I can get on my next test and reach my goal. Okay, goal should be circled. I forgot to do that. Now with goal, we're going to use a greater than symbol. And my goal's 90. You can be equal to 90 as well. Now, how do you do the average rule? Well, we start adding the ones that we know. It has to be a division. So we go 87 plus 97 plus 89, and then I'm about to take another test, which I don't know what I'm going to get, so plus x. Now, how many tests is that? That's 4, including the x. So down here, I'm over 4, and I've got the x, so I'll put that down, and then I'm going to add the 3 tests I've already taken. So 87 plus 97 plus 89. That's going to be 273. Now, first off, get that 4 out of there, okay? You're allowed to cross it off as long as you multiply the other side by 4, and that's 360. So now I have x plus 273, be a 1x, so the sign would stay the same, minus 273. 360 minus 273 is going to be 87. You can divide by 1 or get rid of it, so you can get an 87 or higher and reach your goal. Okay, 17. The specified length of a board is 20.5 inches. The specified width is 25 inches. Each dimension has an allowable variation of at most 0.17 inch. Write inequalities that represent the possible range of each dimension. Okay? Now, length range. What's your length supposed to be? 20.5. The width is supposed to be 25, but it can vary by 0.5. That means you can be over or under, so plus minus 0.15. So I put L and W. So first I add 20.5 plus 0.15. 20.65. Then I subtract, okay, and that's going to be 20.35. Eat the 20.65 and then eat the L. You don't ever eat your minimal. Okay, same thing here, 25 plus is going to be 25.15. And then when I subtract, it's going to be 24.85. Eat the maximum, but never eat the minimum. Done.